Okay, what happened? No, okay, recording. Okay, so let's look at the previous slide. Right? So this is an application of to navigation. So you were wondering, how about example 7 and example 8, right? That we have skipped the 4-part theorem. Okay, the 4-part theorem we have skipped. We have go straight to the application to navigation. Okay, so what is the assumption there? The assumption there is we assume that the Earth is a sphere. Okay, the Earth is a sphere. We already know that. Okay, or at least close to a sphere. How do they find the shortest distance between any 2 points? Okay, they are actually shortest distance between any 2 points are the surface is a great circle. Okay, and you join them by great circle. So join the point by following great circle. That means that this is, let's say you have 2 points on Earth here. So 1 point here, 1 point here, B, right? A and B. Okay, you can join them by the great circle. A great circle is a circle that passes through the center of the Earth. Okay, then the distance usually you can measure in this way, following the surface of the Earth. Okay, to calculate the distance, we need to find a few things. Distance between 2 points A and B. Okay, distance between 2 points A and B, we need to calculate a few things. One of them is, of course, you need to know the position first. I also need to know what is the initial cost. Okay, what is the initial cost? You see that the Earth has a North Pole and South Pole. So the North Pole there, and South Pole here. So depend on the position. Okay, North Pole there, and then there is the initial cost. So initial cost is the you join the North Pole to the point A. Okay, so join the North Pole to the point A, and then this angle here, alpha here, this is called initial cost. Okay, initial cost. Okay, you follow the path from A, travel from A to B. Okay, this initial cost. Which one? Okay, initial cost. And then the beta. Okay, you join the North Pole to the point B, and this beta here is called the final cost. Okay, actually the movement of the ship, in this case, the movement of the ship is in this way, right? This is how the movement of the ship look at. Okay, look at move in this direction. So you draw the angle from the North Pole to this pointing to the North Pole now. Okay, pointing to the North Pole. Then actually initial cost and final cost are actually the bearing. We use the draw bearing in this way, right? Let's say that east north then we say this is the bearing measured for the North Pole. Okay, so this alpha, right? Usually you say this bearing here. This is actually the bearing there, except that we don't draw it in a straight line. We joining to the Earth North Pole. Okay, joining the North Pole, then we measure the angle. Okay, there's the bearing here. So, and then there is also a point called the vertex. Let me show you here. Such a diagram. Okay, so this is illustrated here. This is the diagram. So you have a North Pole. This is a North Pole here. North Pole, and a point A, travel to point B. Okay, and then you join the North Pole to the point A, and this is actually the initial cost. This alpha is the initial cost, which is a bearing here because this is actually pointing to the north. Actually, right? This is pointing to the north. Same thing here. This is also pointing to the north. Okay, so the beta is called the final cost, also the bearing here. Right. So we have some name for this. First of all, the length of PA. Okay, the length of PA is called the co-latitude of A. Okay, the distance from P to A is called the co-latitude of A. Okay, co-latitude of A is the distance from P to A. It's the name, right? Co-latitude of B is the distance from B to B. Okay, usually you measure the distance using degree. Then AB is a great circle distance between A to B, right? And we know that. Okay, so then you can form a triangle, right? From here you can form a triangle already. This triangle, this is bigger triangle, no? So this is bigger triangle. Okay, angle P, usually you can find this. Angle P is the longitude difference between A and B. Okay, longitude difference between A and B, distance of longitude difference between A and B, right? It's angle P. Angle P is the longitude difference between A and B. And then initial critical cost and final cost is alpha and beta. Okay, there's also another point called the vertex, which is the next $2 per one. The examples of vertex here. Okay, what is the vertex? Vertex is a point on the great circle on the surface of Earth which is closest to the pole. What is the vertex here? So vertex nearest to the pole. That means on a great circle. Okay, on a great circle here. So this is a vertex here. Let's say it is vertex. Then the distance from the vertex here, V to P, this is supposed to be shortest. That means that this is 90 degrees. Okay, when it's divided by 90 degrees, it's the shortest distance. Okay, this is a vertex. Okay, okay, so the vertex is a point along the great circle nearest the pole. So nearest the pole, that means the distance, when you join the vertex to the pole, the angle should be 90 degrees. Okay, and usually we also ask to know when is the vertex, where is this point, how much it travel from A to P, A to B. Okay, so this is the initial definition for a great circle. Let's see how many people are here now. Okay, I think hopefully most people are here already. Still have a lot of people are not here now. Okay. Okay, fine. Okay, this will be the important example because starting it take a long time to cover this example. Okay. Let's see a question here. A ship leaves a position, let's say this called A here, okay, 25 degrees 35 minutes north, 60 degrees west, and follow a great circle track. Okay, the initial great circle course at A is 0.68 to 68 degrees true bearing. Right? Find the latitude or longitude of the north vertex of the track. So as I mentioned, what is the mean by north vertex? Okay, what is the mean by north vertex? Find latitude. It means longitude, right? In position now. Latitude and longitude are the position of the north vertex to the track. Okay, north vertex is the point nearest to North Pole now. Okay, north vertex nearest to North Pole along the track. Okay, nearest to North Pole along the track. So let's see what is this thing here. So if you look at the position, okay, so there's a point A. So where is a point A here? A is a point on the Earth. The position is 25 degree 31 minute north and 60 degree west. This position, right? The latitude and longitude. Okay. West, east, west is the longitude, and north, south is the latitude. And this point is called A. And the cost of initial cost, the initial cost, if you join the North Pole, let's say P is North Pole here, the North Pole, North Pole, North Pole. So if you join the North Pole to the A, this is going north, right? So the initial cost is 68 degree. 68 degree is the initial cost. That means that if you move right, actually the ship is moving in this direction, 68 degree. Okay, the ship is actually moving in this direction, 68 degree to somewhere. And then I want to find the point called the vertex nearest to the North Pole. Okay, North Pole is P, so the vertex is somewhere here, V, 90 degree, nearest to the North Pole, right? So I want to find where is this vertex now, nearest to the North Pole. If you ship going at the bearing of 68 degree, okay, going at the bearing of 68 degree, where is the position of a vertex now, nearest to the North Pole? Okay, so this is the first question. Okay, look at the question what they ask. So there are a lot of information. They tell you what is position A, where the position is latitude, longitude, and then they ask you the direction in both, right? For the bearing 68 degree initial cost. So I want to find the vertex now. Okay, so let's try to answer this. You know where's the North Pole angle? North Pole angle is actually 90 degree. Okay, North Pole angle is 90 degree. So first, look at, I want to draw a picture on the Earth so that you can see the picture. Let me have this. Okay, so if you have the, better do this way, drawing the picture, all right? So insert picture first, a few of them. So this one, there's this Earth here. Okay, so A is somewhere. So this is the Earth here. So this is North Pole here, P, 90 degree. And say somewhere here, this is point A. A has a long latitude and longitude, right? Let's say latitude is 25 degree north. Then let's say 60 degree west. Okay, not really 60 degree east. Let's see, So that means the center of the Earth. Oh, so that means what? From here to here is, if we are 25 north, that means that this angle is 25 degree. Right? This angle from the center of the Earth to the point A is 25 degree. Then what is the angle? Okay, then what is the angle from the center of the Earth to the North Pole? Okay, so North Pole is at 90 degree, right? So this angle, that means that this angle this angle here is 90 degree minus 25 degree, right? So this angle here is 90 minus 25 degree, okay, which is actually 65 degree. And this is how we measure the distance in great circle. We always measure the distance in degree first. That means the PA, for example, if you try to measure it, then PA is the distance. If you will measure it, PA is actually 90 degree minus 25 degree, which is 65 degree. Okay, this is the distance of using the spherical triangle to measure the distance between 2 points, P to A. And usually we have a name for this. This is called the co-latitude. Okay, co-latitude of A. Okay, this is how you find the co-latitude of A. So if you go back to the earlier slide here, so you can find, okay, so what is PA now? You know P is the North Pole, right? So latitude of A is actually, latitude of A is actually, for the question is 25 degree, 31 minutes. Okay, north, right? So the distance from P to A, so we call co-latitude of A now is PA is 90 degree minus 25 degree, 31 minutes. So you pass calculator, you find that this is 64 degree, 29 minutes. Okay, that means that this distance here is 64 degree, 29 minute PA. Okay, now what is the cos at A? Initial cos at A is, you can see the angle A here. So cos at A, cos at A. This is the initial cos, right? Initial cos at A. Okay, initial cos, the direction they move is, you can see the angle, it moves from north towards the east, right? The north towards the east, 68 degree, right? So this is 68 degree true bearing. So A is equal to 68 degree. Of course, then where's the vertex? Where's the angle at V? Angle at V is 90 degree because V is the nearest point to the North Pole. So when it's nearest point, the distance from P to A must be 90 degree, right? So vertex at V, angle V now, angle V is, vertex angle V now is equal to 90 degree. Okay, so this is actually 90 degree here. So immediately you have to remember that this is a right angle spherical triangle. Therefore, you can apply Napier's rule. Okay, so can apply Napier's rule, right? So you can do the Napier's rule. Okay, Napier's view, apply Napier's rule. Okay, so now this is a good time to remember. Recall what is Napier's rule later on. Okay, because we may have forgotten already, although this is just recently Napier's rule. So let me draw this triangle and apply Napier's rule. Okay, fortunately this is not too complicated, only one triangle only. Okay, edit, select page, right? So I copy this to the next page here. Okay, copy in the next page here. So this tell you the circle distance. Okay, insert here, next page here. Okay, so I have set up everything already. Now let's do calculation. So edit, selection tool, all this information only down. Okay, vertex nearest point to the Earth, not to the North Pole in this case. So you apply the Napier's rule. It means that you go from right angle is 90 degree, right? Clockwise. So you go from here to here, and then go in. Okay, go in, and then go out. Then you follow clockwise. 90 degree is at the center, V. So draw a Napier's view. Okay, Napier's view first. So Napier's view, right? Which I calculate from here. So Napier's view, you have draw a view first. You have a view something like this, and then divide in two parts. The bottom divide in three parts. Okay, with comb. And then the top is a V. V is 90 degree V. Okay, so when it go into the view, go into the 90 degree, right? This will go in here, go in at PV. Okay, PV, do you know what? How much that number? I just put them first. PV is, start with PV first. Then get out at VA, right? VA, get out VA. So VA. Then come into contact with angle A. Then continue triangle with PA. Okay, PA now. So continue triangle with PA now. Then come to contact with the angle P. Okay, P is this angle now. So P is this angle here. Okay, angle P. So angle P we don't know. Switch angle P. Okay, so we have a Napier's view there, and see what are the information you can fill in. So I know what is PA. PA is 64 degree 29 minutes. Okay, I know what is PA. I know angle A, 68 degree. So straight away you can see how I'm going to approach this problem now. The only thing that help me to find is you have this use a color code here for PV. I want to find PV now, and opposite the PV, I use a blue color. Okay, and this is how I approach the problem. I look at what I have, then the easiest way to find the next information is use a yellow one. Okay, so the information I'm going to do is this one. Just write down here. For Nepier's rule, we know sine of middle part is equal to product of cosine. Okay, product of cosine of cosine. Okay, sine of middle part is product of cosine, and sine of middle part is also product of adjacent, tangent of adjacent. Okay, product of cosine for opposite. Okay, product of cosine for opposite. Okay, and then product of cosine for product of tangent for adjacent. So let me move this away a little bit here. Okay, I'll move this away here. Move a little bit, so I have more space here. Okay, this is actually product of cosine of opposite. So that means that, how do I write down now? This is actually sine of PV, sine of PV equal to, okay, cosine of, now A is below the view, so they have column A. Then cosine of PA also below a view, so you can column PA. Okay, you need a column. So these two are actually the blue portion, cosine of column A, cosine of column PA, and this is the yellow I want to find, PV. The sine of middle part is product of cosine of opposite. So I can find sine of PV now. So let me use the black color again. So sine of PV, I don't know what is PV, I want to find out. This is cosine of com. Now sine of com PA, we last time mentioned that the sine of com A is, com A means 90 degree minus A, right? Cosine of com A is converted to sine of A straight away. Okay, cosine of com A is converted to sine A straight away. Same thing on cosine of com PA is converted to sine PA. Okay, cosine of com A, the same thing as sine A. Okay, we memorize this fact so that easily you don't need to write out so many minus sign. Otherwise, you have so many minus sign to take care of. So that this is sine A now. So this is sine A is 68 degree, and then the sine PA is 64 degree and 29 minutes for PA. You calculate that. So you can find what is this thing now. So you'll get 0.8367, and that's my thing, right? So from here, you can find out what is PV now. PV is equal to sine inverse, okay, 0.8367. So press calculator, you get 56 degree, 48 minutes. Okay, PV. Okay, first of all, how long is the PV? How come we only get one answer now? Of course, normally you can try another answer, right? Another possibility, PV is 180 minus this thing, but we don't need that one anymore because PV is definitely nearest to the North Pole, right? Nearest means the shorter distance. Okay, shorter distance. So this is a correct answer already, right? The other end distance will be too large already. The shorter distance from P to V, you can see on the diagram. Okay, 90 degree is 64, right? 90 degree is 64 degree, 29 minutes. Okay, if you look at 90 degree here, okay, you get 90 degree here, you get 64 degree, right? So now you get 68 degree. How much is the distance now? Okay, 68 degree is smaller than 90 degree. So expect this PV less than 64, right? Degree, 29 minutes. Therefore, you know that this is reasonable answer. Okay, 56 degree, 48 minutes. So this is only one. Okay, this is the only answer. Okay, I actually apply the Napier's view. Okay, so PV, we found that this is equal to, write down straight away. So this is actually 56 degree, 48 minutes. Okay, so this is PV here. Now I want to redraw, copy this to the next page now. Okay, to calculate. Okay, calculate that. Now let's say, let me calculate here. I did copy this one, copy page here, and then copy page view. So go to the next page here and do calculation. Okay, now I want to erase all these things, especially the middle part. I don't need anymore. Okay, middle part PV, I find out the answer already. I write down, so I don't need the middle part anymore because I need no more calculation. So this one I don't need anymore, right? So I don't need this anymore. I don't need this anymore. We're applying the Napier's view. Okay, so let's see. Do you know where is the location of V? V has 2 points, right? One of them is latitude. Latitude is how far out now reducing, and then longitude. Okay, longitude, right? So latitude we know, and then want to find longitude here. So longitude here. So this one. Okay, right properly. Okay, we know PV. Okay, if you look at diagram, PV here is 56 degree 48 minutes. So what is the longitude of, where is the latitude of V? Okay, let me draw the Earth again. Okay, Earth again. So I didn't go back to Earth again. Okay, so draw another Earth again. Okay, let me see. Draw another Earth. So another Earth again. Separate diagram. Don't use the red color one. I'll use the black color one. So use another Earth again. So I have another Earth here. The North Pole. Okay, somewhere here is a V. V is a north pole, nearest to the north pole. Okay, and then you have A here, somewhere here, A here. Okay, this is a triangle. So, you know, A, this center Earth for here. So A, the latitude is 25 degree, right? A's latitude from the question state is actually 25 degree 31 north. Okay, so the question tell you that, okay, if you draw a diagram, this angle here is 25 degree 31 degree north. Okay, so this one, this latitude here, 25 degree north. Okay, this is where the north A, yeah, the A is actually given longitude 25 degree and 31, okay, 25 degree and 31 minutes north. Okay, I don't care about the longitude now at the moment. So longitude weighted is 60 degree west, right? So I think the question says 60 degree west. So you know this A given by the question. Okay, so this is where the 25 degree 31 minute north looks like. Okay, now where is the location of V now? So this length, we find out that this length here, okay, we find out that by more calculation, this is VP is 51 degree, 56 degree, 48 minutes VP. Okay, so what does that mean? So North Pole is 90 degree. North Pole is 90 degree, right? So you have to subtract 90 degree from here. Where is the location now? So the location of V, right? Longitude of V now. So longitude of V. So latitude of V now. So latitude of V. Okay. So you want to find latitude of V now. Of V is how much? Just take 90 degree. I don't know where this longitude, right? So you just subtract this one or two. Okay, because from here to the North Pole is 90 degree. Okay, from here to North Pole is 90 degree. So you have to go how much is this angle now? So it's just 90 minus 54 degree 48 minutes, and then you get 33 degree 12 minutes. Okay, so that means that I know the distance PV. That means that if I go from the center of the Earth, from the equator, okay, from the equator, let's see here, this angle is actually from the equator. This angle is 33 degree 12 minutes. Go from the equator. Then you get the vector. Then you get the point V. That means if you go from the equator, go up the direction 33 degree 12 minutes. Okay, this is how you get the point latitude of P. So that means that I can do a calculation. That means write something here. So I know that PV already So the latitude of V now, latitude of vertex. So latitude of vertex here. Of the vertex is equal to 90 degree minus 54 degree 48 minutes, and this is 33 degree 12 minutes north. Okay, this is the latitude of V, how high it is. Okay, the picture is actually inside this sphere I give you, right? The given this, you see, find the latitude now. Okay, inside this sphere. So you mean the meaning of latitude of A means you go from equator, go up 25 degree 31 minutes, get point A. You want to find latitude of V means go from equator, go up. In this case, find as 33 degree. Okay, because the distance from the equator, the angle from equator to the North Pole is 90 degree, right? This is equator here. Okay, so this is equator here. Okay, so this is equator. Okay, so that finish the no yet last, so a lot of work to do. So I have the two information already, right? So next thing we see what do you have now. So let me copy this to the next page. Okay, edit, select page here, edit, copy page here. Okay, put that in. Okay, so let me erase some information. Okay, I know the latitude of V already. It's 33 degree 12 minutes. Let me erase this information now. Let me also erase the color. I don't want color here now. So what are the things I have now? I can find, for example, what is angle P, right? Obviously, I can find angle P. So angle P is the target now. Okay, I can find angle P now. Okay. Then, of course, the information I have now is actually two adjacent now. Adjacent now. So I use Napier's rule now. This time is another Napier's rule. Is sine of middle part is product of tangent adjacent. Okay, so this is a product on middle part. Middle part is the yellow one. Adjacent, I use the green color, right? The green color for adjacent. So this will give you, this is P now. P again is in the lower half, so you must have com P. Okay, com P lower half, because it's in the lower half there, so this one must have com. And this is equal to product of tangent of adjacent. One of the term is PV tangent PV. Okay, then PV don't need to count, but PA we need to count now. Tangent count PA. Okay, PA need to count because PA is in the lower half of the view. So let's use the green color again. Now you can simplify it. Okay, remember this tangent PV. Now, tangent of cone PA. We know that tangent cone PA is 1 over tangent A. PA, right? Can simplify this already. Tangent of cone PA is 1 over tangent PA. We put it down. So let's do calculation here. So this is tangent of 56 degree 48 minutes over tangent of PA is 64 degree 29 minutes. And sine con P. Sine con P is equal to cosine P. So it's very good news because it saves you a lot of calculation. Cosine P, right? So this cosine P. The sine con P is actually cosine P. So what is this going to give you? Okay. So this one I need calculator because different story already. So let me press calculator, right? So to get tangent of 56 degree, okay, 48 minutes divided by tangent of 64 degree 29 minutes. Okay, so they will give you 0.729 4. So P is equal to angle P, yeah, is cosine inverse 0.7294. Okay, what is this equal to? Shift cosine inverse now. Shift cosine inverse. Answer. This is 43 degree and 10 minutes. Okay, this angle P. So this angle P here, 43 degree 10 minutes. So where's angle P? It's the blue color one. This angle P now. So this angle P. Okay, we find out it's 43 degree 10 minutes. Okay, so let me erase the 90 degree here. Okay, what is the significance of this angle P? Okay, what is the significance of this angle P? This is 43 degree. You know that this is actually the ship actually going toward east. Okay, so the point A is at 60 degree west. The point A is 60 degree west. So the actually from the direction the movement is actually toward east. Right? Point A move this way, right? I don't see. I wonder if you carry out the direction of movement. This is cos, right? Initial cos. Initial cos is if you don't draw the arrow now. So the movement of the ship is going at 68-degree bearing. So this is where it moves, okay? Direction of movement, it moves this way. Okay, move the east side. Okay, so if you know that this is starting from 60 degree west, so move to the east side. What is the longitude of V now? So you can find that longitude of V, so that means that longitude of V is equal to 60 degree minus 43 degree 10 minutes. Okay, you have to move to the east side. So the latitude, okay, so longitude will decrease, right? Because the east side increase how much? So this is actually towards the location 60 degree west minus 43 degree. Again, you get this one 16 degree 50 minute west. Okay, so now you know that this, you can answer the question now. So this is latitude. We find that V, V, the location of V, we find that, okay, location of V, okay, right down here. The latitude, the longitude is 16 degree 50 minutes west. And the latitude, just now we find out, is actually go up. The latitude is actually 33 degree. Just now, 12 minutes north.
Sir.
Yes.
My calculator, when I calculate the angle of P, right, I got a different answer.
What answer you get?
I got 46 degree and 50 minutes.
Something is wrong like that. The answer, I think I get 0.7294, right?
0.7294, yes, correct.
You know, I mean, I tried again. How can your calculator got different answer? Cosine inverse. Make sure in a degree mode. Okay, cosine inverse. So they get shift cosine inverse. We calculate again. Cosine inverse 0.7.
Oh, cosine inverse.
Right? And cosine inverse, no?
Okay.
Okay, you get 43 degree 25 minutes. Sorry, 43 degree. Yeah, it's not really 7294 lah, because I just take approximation. Okay, so you use the same answer, original answer, you get 43 degree 10 minutes.
Okay, sure thing.
Okay, it's not exactly 0.294. I just write there that actually a long string, no, there's no point. I can just take the answer there. Okay, so that is example 9. I finished all the things. That what is actually inside this example? Let me explain to you. A lot of things are inside this example, right? So I need to answer a few things. I use this one. Okay, so imagine that you're North Pole or South Pole. Okay, so when I talk about initial course, basically is the bearing of the ship. Okay, bearing of the ship, where direction it head to, initial course. Final course is final when it reach the port, for example, where is the direction it actually go to, because the direction will change based on the direction of going to the North Pole, right? So this arrow here tell you where you go to the North Pole. Okay, so in this case, tell you, okay, and then the information, there's a vertex we're looking for, and vertex is the nearest point to the North Pole or South Pole, depending on which direction you move. Okay, and then when example 9, okay, we have to find out what is the latitude of A, and then from there you can find PA, right? PA is called the co-latitude of A. Okay, why is it like that? Okay, if you look at the picture, I think I'll show you how to normally calculate the blue, this is the blue one. Okay, it's co-latitude. Okay, once you know latitude, you can find the co-latitude as blue one, and then angle A is given. Okay, that is the initial cost. Okay, which direction I move from the North Pole. Okay, PA is that AP is direction on to the North Pole. Okay, then because I want to find that vertex, you use a 90 degree to find the distance. So this time we use a Napier wheel. Okay, so on the Napier wheel, you check. Okay, one is a product of cosine. All right, sine of centimeter part is the product of cosine of opposite. So from here, you find out what is PV. Okay, once you know PV, you can find the latitude of V now. Okay, once you find PV, you can find latitude of V. Just 90 minus the distance PV, you can find latitude with 33 degrees 10 minutes. Then I want longitude, I want to find P now, angle P. So find the angle P, you find that this is 43 degrees 10 minutes by using sine product, equal product of tangent or adjacent. So once you know P already, you know how the shift move to the east side, right? So latitude, longitude of V now, because the shift go to the east side. So from 60 degree start, from 60 degree start here, you move to the east side. So you decrease now, because when you start from 60 degree, you must decrease, move to the east side, the longitude will decrease, right? So decrease by how much? 43 degree 10 minutes. So you get that and longitude is 16 degree 15 minutes now. Okay, so this will stop the problem. Let me stop recording now. Okay, stop recording.